In this section, we're going to focus on theorems about perpendicular lines. We're really going to focus on the reasoning behind the conclusions that we make. So our goal for today is to use theorems about perpendicular lines in order to make conclusions about different lines and different angles. Alright, so the first theorem that we're going to talk about seems kind of obvious. It says that all right angles are congruent. And hopefully this makes sense to you because a right angle is an angle whose measure is 90 degrees, and any angle whose measures are equal are congruent. So if we see this picture here, we can see that angle A is a right angle. We know it is because it has the little box in it. Angle B is a right angle. Therefore, we know that angle A is congruent to angle B. So we're going to use this theorem in order to make some other conclusions as we go along. The next theorem we're going to talk about says that if two lines are perpendicular, then they intersect to form four right angles. And again, this should make sense because if it intersects to form one right angle here, and this is a straight line, we know, for example, that these two angles are supplementary, so they have to add up to 180. So if this one is 90 here, this one has to be 90 here. In addition to that, you could use the vertical angles theorem. If angle 1 is 90 degrees, angle 1 and angle 3 are congruent. Therefore, angle 3 is 90 degrees and is a right angle. So we can use this kind of reasoning to conclude that all four angles are right angles. So another way to say this is that if line N here is perpendicular to line M here, then the measure of angle 1 is equal to 90 degrees. We would also say the measure of angle 2 is equal to 90. The measure of angle 3 equals 90. And of course the measure of angle 4 is equal to 90 degrees. Alright, so we have our two theorems. All right angles are congruent, and if two lines are perpendicular, then they intersect to form four right angles. So here's our first example. In this particular diagram, we know that line R is perpendicular to line S, and we know that line R is perpendicular to line T. So we want to determine whether each statement is true, and we want to provide a justification. So statement A says angle 3 here is congruent to angle 5. We know that this is true because we can see from the diagram that angle 3 is a right angle. We can see from the diagram that angle 5 is a right angle. Therefore, angle 3 is congruent to angle 5 because all right angles are congruent. That's that first theorem we talked about. So it seems rather obvious, but we're focusing on the justification here. Alright, now the next statement we have says that angle 4 is congruent to angle 5. Well, let's back up here a second. We knew from the beginning that line R was perpendicular to line T. So R and T are perpendicular. Because R is perpendicular to line T, I now know that angle 4 is a right angle because perpendicular lines form four right angles. Alright, so that's the first part of the justification. Now I know that angle 4 is a right angle. I also know that angle 5 is a right angle. So now I can make the conclusion that angle 4 is congruent to angle 5, again, because all right angles are congruent. Okay, perfect. Now let's look at the last one. We want to show that angle 2 is congruent to angle 3. Now if I look at angle 2 is formed by line R and line U. So line R and line U. If I go up to the given information, all I knew was that line R was perpendicular to line S and line R was perpendicular to line T. I don't know anything about the relationship between lines R and U. So while angle 2 might look like a right angle, I don't know for sure that it is. In fact, really line U could be going something like this and forming angle 2 here, and clearly in this case it's not a right angle. We just don't really know what's going on with line U. So I cannot conclude that angle 2 is congruent to angle 3. There's not enough information to make that conclusion. Alright, so I want you to check these exercises on your own, or try these on your own and then check yourself. So in this particular diagram, we know that line G here is perpendicular to line E here. We also know that line G is perpendicular to line F. So you can see we have a right angle at 6 and a right angle at angle 10. Think about what other angles have to be right angles there. And I want you to pause the video here and not only determine whether each statement is true or false, but also give a justification. So pause it and try it, and then when you resume, I'm going to give the answers. Okay, so for number 1, angle 6 is congruent to angle 10. That's true. And the reason is because they're both right angles, as seen in the diagram, and all right angles are congruent. In number 2, we have angle 7 is congruent to angle 10. That is also true. The justification would be that angle 7 is a right angle because line G is perpendicular to line E. Therefore, angle 7 is congruent to angle 10 because all right angles are congruent. In number 3, we have angle 6 is congruent to angle 8. This is false. Angle 6 is a right angle. I don't know what angle 8 is because I don't know about the relationship between line H and line E. Number 4, angle 7 is congruent to angle 11. This is true. Again, first we know that G is perpendicular to F here. So that means that angle 11 must be a right angle because perpendicular lines form 4 right angles. Then I can make the conclusion that 7 is congruent to 11 because all right angles are congruent. Next is 7 is congruent to 9. That is false. Again, angle 9, we don't know if that's a right angle or not because we don't know any relationship between line H and line E. We don't know that those are perpendicular. And the last one, angle 6, is congruent to angle 11. Again, this is true. To begin with, we knew angle 6 was a right angle. Then we make the conclusion that angle 11 is a right angle because G is perpendicular to F. Therefore, angle 6 is congruent to 11 because all right angles are congruent. Alright, so our next theorem says, if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. Remember that adjacent means next to each other. So what we're saying here is, look at this picture. We've got angle 1 and angle 2. They're clearly adjacent. Not only that, but they're formed by two intersecting lines. So it's not any pair of adjacent angles. It's adjacent angles that are formed by two intersecting lines. So if that happens, and I know that angle 1 is congruent to angle 2, then I know that these lines are perpendicular, and so that they have to form 4 right angles. So if I know angle 1 is congruent to 2, then I know that line AC is perpendicular to line BD. So our last theorem says that if two sides of adjacent acute angles are perpendicular, then the angles are complementary. So what we're saying is if we have two angles like this, angle 3 and angle 4, and we know that both of these angles are acute, in other words, they're both less than 90 degrees. If I know that the two sides, EF and EH, if I know that these two sides are perpendicular, then I know that angle 3 and angle 4 are complementary. In other words, that they add to 90 degrees. So in symbols, what we say is that if we know that ray EF is perpendicular to ray EH, then I know that the measure of 3 plus the measure of 4 is equal to 90. So our two theorems here are, if my adjacent angles are congruent from intersecting lines, then my lines are parallel. And If I have two adjacent angles whose sides are perpendicular, then I know that the angles are complementary. So, in this example, we have a helicopter. Can we conclude that angle AXB and angle CXB are right angles? So AXB is here, CXB is here, and yes, I can conclude that they are right angles because they are adjacent, they are congruent, and they are formed by intersecting lines. Okay, and the only reason, by the way, that we knew that they were congruent is because these marks here in the picture indicated that they were congruent. Alright, so here's some algebra. Let's solve for y in this picture. We can see that EF is perpendicular to EH, so we know this is a right angle. That means that we know that these two angles are complementary. In other words, that they add to 90. And we know that the measure of angle GEH is 30 degrees, and that's been labeled in our diagram. So my equation that I can set up is 6y plus 30 equals 90. Subtract 30 from both sides in order to isolate y. So we'll get 6y is equal to 60. Divide both sides by 6. And we get y is equal to 10. So have we answered the question? Yes. Solve for y. Y is equal to 10. If the question asked me find the measure of angle FEG, I'd plug that in. 6 times 10 is equal to 60. Alright, so let's just try these on our own to see if we've got it. Find the value of the variable in the picture and explain your reasoning. So pause the video, try to find the value of each, and explain your reasoning as you go. Then replay the video to check your answers. Alright, in number 7, we can see that we have EFG. Angle EFG is congruent to angle HFG, so these two angles are congruent. I also see that they're formed by intersecting lines, and they're adjacent to each other, so that means that angle EFG is a right angle. Right? So I know that this is 90 degrees. So I can say 5x has to equal 90 degrees. Divide both sides by 5. And we get x is equal to 18. In number 8, I know that AB is perpendicular to AD. So this is 90 degrees. That means these two angles are complementary. So I can set up the equation 36 plus 9y is equal to 90. I will subtract 36 from both sides to isolate y. So we get 9y is equal to 54. Divide both sides by 9. And we get y is equal to 6. And the last one, again, I know KJ is perpendicular to KL. So this is 90 degrees. And I know that these two angles are congruent. So they're both labeled with the same measure. We called it Z. In this picture, you could just as easily use X. Z plus Z is equal to 90. Simplifying that gives me 2Z is equal to 90. And dividing by 2 gives me Z is equal to 45. And that's it. So hopefully you got those 3 right, and you'll be able to work on some practice in class.